Bhaskar, Assistant Professor, Department of Computer Science and Engineering, Anna University, Chennai. Area of specialization is software engineering and database system. Guided more than 12 research scholars, published more than 40 national and international papers. Is a reviewer and editorial board member in international journals.
Welcome to UGC lecture series in computer science. In this series of lectures, we are looking at software engineering as a specific title. Till now on, we have seen different titles like different software development models. We have looked at use case diagrams, and now we will look at software project planning. After the finalization of SRS, we would like to estimate the size, cost and development type of the project. Anything which has to be estimated. When I said project planning, we just need to estimate the budget, the time and the size. So these are the three important tasks that are to be performed before I start actually implementing the work. So this can happen after the finalization of SRS even. So after the finalization of SRS, we would like to estimate size, cost and development time of the project. Also in many cases, customers may like to know the cost and development time even prior to the finalization of SRS. Maybe when I am in consultation with the customers, if suppose I am a developer, prior to the finalization of software requirements specification, our customers might want to know what would be the rough budget for the project and the rough development time. So this need to be estimated at whatever level it might be, but either it can happen before the SRS or it can happen just after the SRS is complete. Project planning must incorporate the major issues like size and cost estimation, scheduling, project monitoring and reviews, personnel selection and evaluation and risk management. The first thing talks about size and cost estimation, where we estimate the size in terms of the number of codes being written. If suppose it is a programmatic solution, we estimate in terms of number of lines of code, which we call it as LOC. Generally this LOC is measured in terms of thousands. So we generally measure it as KLOC, where K is for kilo. So size is one of the estimate which is to be done. Based on the size we can estimate the cost and schedule, rough time and project monitoring, when all which I need to monitor, what are the aspects which are to be monitored, and reviews, who are the set of person who will be selected for such a kind of a work. So by personnel selection I will be going for effort estimation. So effort is generally measured in terms of person months, and evaluation and risk management. For a successful project, what all the points which we need to understand are: first we need to define the scope of the work to be done, the risk to be incurred, the resources required for effective development of the project, task to be accomplished, cost to be spent, schedule to be followed. So these are the 6 factors which we need to keep in mind before I start with the actual project. So scope of the work, what will be the scope from 10 years from now, how will be the scope of the project, the risk that are to be encountered. Basically now you can recall risk we have talked about in spiral model, which is just to evaluate what are the factors that might be risky when I move on for the development. Resources in terms of persons, resources in terms of infrastructure developed and things like that need to be talked, and tasks that are to be accomplished, cost and schedule. Activities that are required for effective software project planning are: 1. I will go for the size estimation initially. After I estimate the size, I will go for cost and I will go for development time. So these are 2 separate activities which are done concurrently. After estimating these 2 things, I will go for resource. So based on resource, I will be estimating my project scheduling, and development time will also be helpful for understanding the project scheduling. This is one certain example which is given for estimating the lines of code. If you take the lines of code, if LOC is simply a count of number of lines, then the figure shown contains 18 lines of code. This is just for a problem which sorts array in ascending order, for which I write 18 line program. So this is a structured programming where I have taken up totally 18 lines for doing this program. Just for example, if I take $10 to execute every line of code, I write the command for the programming and I take $10 for every line of program that is being written. This program takes $180 for its compilation. Further, if you look at the lines of code, furthermore, if the main interest is the size of the program for specific functionality, it may be reasonable to include executable statements. The only executable statement in the figure are in lines 5 to 17, leading to a count of only 13 lines of code. The difference in the counts are 18 to 17 to 13. One can easily see the potential for major discrepancies for large programs with many commands or programs written in a language that allow a large number of descriptive but not executable statement. What I mean by here is, we just have to look at the same table which I have referred you. If you look at this table, line 4 mentions the comment for the programming. If you omit this line comment, it means actually 17 lines of code that has been done, of which the proper executable code would be from 3 to 15. So this is the area which we are supposed to concentrate. So the total number of lines of code required for executing this program would be only 13. So but then we are writing 18 lines of code. So for a simple program like this, we could avoid doing $180 cost to $130 cost estimation. This is called code optimization scenario. So how exactly we can define the lines of code? So Cont is one who has defined the number of lines of code. A line of code is any line of program text that is not a comment or a blank line, regardless of the number of statements or fragments of statements on the line. This specifically includes all lines containing program header, declaration and executable and non-executable statements. Even it says the comments are also inclusive. So it includes the program header, declaration, so whatever you tend to declare with integer, that is also countable, and the loops and other printf and scanf statements which you write, those are said to be, and non-executable statements something like comments are also inclusive of the lines of code count. So this is as per the definition of Cont, but basically given a particular programming, we are not supposed to assign the cost based on the total number of lines of code. Say one person would have gone by the optimization procedure where the same concept would have been presented in 10 lines of code, but somebody else would have been written in 18 lines of code, which is totally differing. Say in the first statement, first programming, I might have given only $100 for him, and the second person I would have given $180, which could not be effectively justified. So what could be the effective measure over which I can project on the cost? So one particular aspect where I will concentrate on the cost factor is the function count. So what kind of functionality that is involved for studying the cost? So we estimate using function count methodology. Alan Albert, while working with IBM, recognized the problem in size measurement in 1970s and developed a technique which he called as function point analysis, which appeared to be a solution to the size measurement problem. Whatever might be its size, what we need to understand is we need to study the functionality involved with those kind of work. So the principle behind Albert's function point analysis is that a system is decomposed into 5 functional units. One is said to be the input where information is entered, output information leaving out of the system, enquiry request for instant access to the information, internal logical files information held within the system, and external interface files information held by other system that is used by system that is being analyzed. So we just have to count on all these 5 parameters which we will assign with a keyword. If you take for example the external input, whatever sets of input, like we have taken a common understanding of a title called student result management system. Of this, the external inputs are supposed to be the student's roll ID, student's name, different marks that he has got, different subjects, and who are the staff members who have handled the class. So if all these 5 are the inputs given to the system, what we would expect out of the system is only the result in terms of performance. So the output should be in the format of the information leaving the system. Enquiries, what could be the possible set of enquiry? How was the result percentage last year and how is it this semester? So internal logic files, how those logical issues have been handled, and external interface files, for anything, any reference that has to be made, it just has to reference. FPAs, the different functional unit, as I have said, so these are interconnected in this format. User are the person who are supposed to give the input, and user are the person who are supposed to get the feedback also, where this internal logic files are the system where exactly the processing is to be done. At times, if suppose any queries being posted by the user, that will be fetched for the internal logic files and that will be returned to the user itself. And there are external interface files which will handle some of the external concurrences which are to be handled here. So let us look at in detail what are the different functional types which you have studied. There are 2 different categories of external functional type units. One, data function type. Within data function type we will study about internal logic files. A user identifiable group of related data or control information that is maintained within the system. Anything or other than that, if that is maintained within the system, those are said to be internal logical files, and anything that has to get its reference from the external system, those are said to be as external interface files. A user identifiable group of logically related data or control information referenced by the system but maintained within another system. This means that EIF counted for one system may be ILF in another system. Let us have a small break. After the break we will look at all the functional types. Welcome back after the break. Before the break I just started explaining to you the different function types. You basically have 2 different function types. One is said to be data function type, the other function type is a transaction function type. So the 5 functional units are divided into 2 categories. Data function type, within that you have 2 categories. One is the internal logical files, the other one is said to be the external interface files. In the internal logical files, a user identifiable group of logical related data or control information maintained within the system. And in the second type of a function type, where external interface files, where a user identifiable group of logically related data and control information that are referenced by the system but maintained within another system. So this is exactly means EIF counted for one system may be an ILF for another system. So the second function type is a transaction function type, where we have 3 different values: external input, external output and inquiries. So with external input, an external input processes data or control information that comes from outside the system. So this EI is an elementary process which is the smallest unit of activity that is meaningful to the end user in the business. So whatever the user wishes to give initially from his input end will be given as an external input, that will be of transactional type, and what he gets out of the system would be of external output type. So an EO is an elementary process that generate data or control information to be sent out to the system. And external inquiry, EQ, is an elementary process that is made up of an input output combination that result in data retrieval. So anything that is stored in the database and to be retrieved will be with the inquiry. So we will have to consider some special features for this function point approach also. So function point approach is independent of the language, tools or methodologies used for implementation. Although we might have lot of tools which can exactly count the function points, but then generally said this is independent of language, tools and other methodologies, but we have framed up lot of tools which can actually count on the function points. Basically we have coined this by use of the number of lines of code. Instead of looking at the number of lines of code, we have gone with all these 5 parameters: external input, external output, external inquiries, internal logic files and external interface files. That is, they do not take into consideration programming languages, database management system, processing hardware or any other database technology. So nothing of this type would be involved for creation of your function point count. So other special feature of the function point analysis is function point can be estimated from requirement specification or design specification. As I have already pointed you, this particular function point count would be starting with either before SRS count take or after the finalization of SRS. So estimated from the requirement specification or design specification, thus making it possible to estimate development efforts. So what is the effort which is required for developing this particular project has to be estimated and early phases of the development. After estimating, so much of pressure was put forth and so much of manpower was utilized. Instead of saying it that way, we just have to estimate roughly how many people are to be there for development of this project. Function points are directly linked to the statement of requirements. Any change of requirements can be easily followed by a re-estimate. So whatever we wish to re-estimate, if we make some changes on the function point on some, we can re-estimate and count the function points again. Function points are based on system users external view of the system. Say given SRMS system where the user specification will be different at different levels of perspective. System users external view of the system, non-technical users of the software system have a better understanding of what function points are and for measurement purpose. So we just need to have to go for counting the function points. So how exactly we have to take up all these parameters whatever we have mentioned and the corresponding weighting factors that are assigned by estimating different iterations. So we would do lot of iterations and we have given here 3 different weighting factor values, one to be as low, average and high for the different parameters which are said to be the data processing functions and the transaction processing functions. So these are the functional units which we are going to consider and the corresponding weighting factor if it is low, if it is average and if it is high. So one said external input, when the weighting factor are said to be low, it has to be assigned with the value of 3. One said input, if the weighting factor is said to be average, it should be assigned with the value of 4. Likewise, if it is high, it should be given a 0.6. So these are iterative values which we have got it after repeated set of iteration with different application based projects. How exactly to count UFPs? UFPs are supposed to be called unadjusted function points. So how to estimate the UFP based on the calculation table which I have shown you before. So for all the functional units whichever I have mentioned, external input, external output, inquiries, logical files and interface files, we just have to take the count complexity which will be estimated as per the customer requirement. So these are to be explicitly plotted in concurrence with the customer and with the developer. So these values will be initially given. So how many numbers are at the low range, how many are at the average, or how many are said to be as high complex works. Likewise, for all the functional units we have 3 different classes, which is to be multiplied with the weighting factor values, which are said to be the complexity totals. After you sum up this particular column, you will get a value which is the functional unit total. This functional unit total is said to be an unadjusted functional unit total, where we have not gone with any extra parameters. We purely rely on only these 5 parameters. Likewise, we just have to calculate for the external output, where we consider 3 values of complexity, multiply it with the corresponding weighting factors, we will get some value that is said to be the unadjusted function point for the EO. Likewise, we are supposed to calculate for all the 5 parameters. So once when you sum up all the 5 values, that value is said to be as the total unadjusted function point count. So you just have to understand what unadjusted function points mean. The weighting factors are identified for all functional units and multiplied with the functional units accordingly, multiplied with the complexity functional units. The procedure for calculation of unadjusted function points is given in the table which I have shown you before. So now that we need to understand how exactly to calculate the unadjusted function points, we have a formula for calculation of unadjusted function points. U of p, which is unadjusted function points, is equal to summation of I is equal to 1 to 5, summation of j is equal to 1 to 3, zij into wij. This z is said to be the values which are fed by the customer and in concurrence with the developer. So those complexity values are said to have z values. So zij, which means I is for the number of functional units and j is for the number of complexity adjustment values. So as said here, I indicate the row and j indicates the column. It is the entry of ith row and jth column of the table, and it is a count of number of functional units of type I that can be classified as having the complexity corresponding to the column j. So this is said to be a independent functional unit multiplied by the weighting factor wij. When I mean z of I13, it means z1, where 1 stands for external input and 3 stands for the high complexity count. So z13 means external input, high complexity count, multiplied by wij. So this j is equal to 1 to 3 stands for the 3 complexity adjustment factors, low, average and high, and I is equal to 1 to 5 stands for all the 5 functional units, which when multiplied you will get unadjusted function points. But our intention is just to calculate the function points on a whole, where this particular function point might take up a threshold value. Whatever we calculate will be an unadjusted function point count, which were purely based on all the 5 functional units, but then that will not be specific. Maybe some other external factors also would come into picture. So we just had to multiply this unadjusted function points with all those external adjustment factors. So our objective is to find out function points, which are organizations that use function point methods develop a criteria for determining whether a particular entry is low or average or high. Nonetheless, the determination of complexity is somewhat subjective. So depending on different levels of people perspective, this subjective matter turns. So I might say this particular work getting done with seeming to be of low complexity, where for somebody else, for developing the same application of same complexity type, he might say the complexity level is high. So this is what the threshold which I meant by. So this threshold need to be completely brought into picture. So function point is to be calculated using this formula. Function point is equal to unadjusted function points multiplied by complexity adjustment factor. Already I have told you how to calculate the unadjusted function points. U of p is equal to summation of I is equal to 1 to 5, summation of j is equal to 1 to 3, zij into wij was the formula to calculate unadjusted function points. Now that we need to understand what CAF actually means, and we have to find out how to calculate the complexity adjustment factor. So to calculate the complexity adjustment factor, CAF is the complexity adjustment factor, and to calculate it is equal to 0.65 plus 0.01 into summation of I is equal to 1 to 14 Fi, where this I is 1 to 14 are the degree of influence and are based on the responses to the questions. People will have a basic set of questions in their mind, like you wanted a regular backup to be retrieved, or you wanted some backup files which are to be taken if the system crashes. So likewise I am to post 14 different set of questions. So people have to understand and let to know the developers those 14 questions. So based on that a threshold value will be set. So that threshold value is multiplied by 0.01 plus 0.65 which brings you to complexity adjustment factor value, which when multiplied with unadjusted function points gives you the actual function point count. So the complexity adjustment factor count might vary between 0 and 5. So when with weighting factor value, as we have altered with low, average and high, here complexity adjustment factor we have to alter it with 0 to 5. So 0 means no influence, 1 means incidental, 2 means moderate, 3 means average, 4 means significant and 5 means essential. Now we have to sum up what we have seen in this particular session. We have started actually with how to effectively plan for the software project. Initially cost need to be taken care, time need to be taken care and effort. So for identifying this can be done at two different levels, either before the SRS being actually plotted up or after the finalization of SRS. For that, lines of count won't be the better methodology to find the cost. Instead we have gone for function point count, which I have taken you through. Some of the questions in this particular session are: what is the need for going in for function points? List the various functional units. I think I have given you 5 different functional units. What are the parameters that can be computed using function points? Thank you.